series of videos on differentiation. So the first one is differentiating polynomials and functions. If you listen to all the videos here, you will pretty much be able to learn the whole differentiation standard. And then later on in my videos, I'll be going over some exam questions as well. So let's start. So the first one looks like a simple polynomial. So whenever you're doing something like this, you have to write either dy over dx or you have to write y dash. The rule is that you bring this 3 in front of x and multiply by the coefficient, which is 1 here. So it becomes 3x, and then you decrease the power by 1. So what are we going to do now? You're going to multiply 2 with this 2, which gives you 4, decrease the power by 1, which gives you x to the power of 1. Plus, you're like, oh, there's no power of x here, which means it's 1. So you're multiplying 3 and 1, which is 3x. And what are we doing? We are going 1 minus 1, which is 0. And then you're like, what is happening with the 5? So normally, when you're differentiating, you're like, oh, the 5's gone. But where is it gone? So basically what happens is it's got no x. That means it's got x to the power of 0. So what is technically happening is that you're multiplying the 0 with 5. And then we're decreasing the power by 1. Correct? That's what's happening. Now this is 3x squared minus 4x. And you know that anything to the power of 0 is 1. So it will become 3. And this whole thing, the reason it disappears is because anything getting multiplied by 0 is going to give you 0. So do you have to do all the methods here like this that I've shown you? Not really. For these two terms, you can straight away write the answer, which is what I'm going to do next. Now here, when I look at this root, what is the meaning of root? Root actually means x to the power of half. Plus 3, so I've not differentiated, so I've just kept it as y. Now I'll go y dash is equal to 2x minus, you bring half in front and decrease the power by 1. So basically you're going half minus 1. And now you know why 3 is disappearing, okay? Because also when you say y equals to 3, it's pretty much a horizontal line. And you know that anything which is horizontal, the gradient is 0. So y dash here is 2x minus half x to the power of negative half. You can just leave it like that because these are pretty much achieved questions and you don't have to simplify them. So let's go to the next one here. Now the problem here is that the root is in the denominator. So first thing I'm going to do is I'm going to go 4x to the power of half. So what do? We can make it as 4x to the power of negative half. That is another thing that hopefully you know, that when you're taking a power from the denominator to numerator, the sign of the power changes. So for example, if you have, just clarifying this. So if you say, for example, you've got 3 divided by x squared, I can write it as 3x to the power of negative 2. Okay, so now I have got what I have to differentiate here. So now I'm going to go y dash is equal to, now you know the method, 4 times negative half, and then we're decreasing the power by 1. At this stage, guys, if you are struggling, you can please use the calculator. That will give you negative 2x to the power of negative 3 over 2. Again, if you're struggling with simplifying fractions, please use a calculator. Now, the next question that I have here is something divided by. Always think simple. Think, how do I simplify this? So the easiest way to simplify this is 3x squared divided by 2x minus 4x divided by 2x plus 3 divided by 2x. Make sense? That what I've done is each every term I've divided by 2x. So if I simplify this, there are two x's on top, one at the bottom. So if I get rid of that, so this is 3 over 2 times x minus x and x gets cancelled. That gives you 2. Here, from the last example, now you're like, okay, I can take the x up. It becomes negative 1. So the power becomes negative 1. See, so far I have not differentiated this function. Now I'm going to differentiate it. So I'm going to write dy over dx. You can write y dash as well. But you have to write it. Otherwise, you have not differentiated it. So there's, what's the power of x here? The power of x is 1. So it is 3 over 2. You know that 1 minus 1 is 0. So that's gone. Now you know that when it is just a constant, the differentiation of that is 0. So that's gone as well. I'm multiplying negative 1 with 3 over 2. So that's negative 3 over 2 x to the power of negative 2. Because I'm decreasing the power by 1. Again, no need to simplify. Now, when you look at this, please look at this question as you are in year 9. What do? You would have expanded it. So this is x squared minus x plus 3x minus 3. So that gives you x squared plus 2x minus 3. Now you go y dash, which is 2x plus 2. Now, in order to introduce differentiation of functions, I have actually taken what is there in your formula sheet. The formula sheet, you can see that they've given you y or f of x, and they're saying the differentiation of that, which is dy over dx or f dash of x, gives you this. So if I have to use this formula sheet, it should be quite self-explanatory. So that's what I'm going to do. I'm going to take the first one here and write y equals to ln of x. Now what is the formula sheet saying? That differentiation of ln of x is 1 over x, and we are done. Number 2, they're talking about an e function, but they're saying take the function as, say, e to the power of ax. That means, say, for example, 2x. And what are they saying the differentiation would be? Y dash is that 2 comes in front. It is e to the power of 2x, which clearly shows that if you have a function, say y equals to e to the power of x, the differentiation of an e function is an e function itself. Now, you can see now that from here, there is a series of trig functions. And it is very, very simple. At this stage, I would have liked to introduce something called a chain rule, which I'm just going to introduce it here simply so that I can explain to you how it works. But let's take a simple example here. If I'm going y equals to sec x and I want to differentiate it, I will look where sec x is. It's here. And differentiation of that is sec tan. So I'll go y dash is sec x tan x. Similarly, say if I want to differentiate cot x, y dash will be negative cosec squared x. There's only one more function which is not given here because that's an exponential function as well, and that is of the form 2 to the power of x. So if I want to differentiate it, it'll be y dash is equal to 2 to the power of x. Why have I written that? Because you just learned the differentiation of an exponential function here is, you can see that it is an exponential function itself. So if you go 2 to the power of x, it will be 2 to the power of x times ln of the base, which is 2. If that is the case, then the question that comes to your mind, or should come to your mind, is that when I'm differentiating, e to the power of x, and if I'm saying that's an exponential function as well, I just wrote e to the power of x. I did not go ln of e. You can, but ln of e is just 1. That's why we don't write it. Whereas ln of 2 has a value. Hope that's clear. So what we have done so far, I'm just going to just do a quick recap. So we have learned to differentiate functions like a simple polynomial, the one which I'm writing now. How do we differentiate? We go y dash is equal to 4x cubed minus 9x squared. You know differentiation of 5 is 0. The second thing that I emphasized was if you have a square root. So now what I'm going to do is I'm just going to make it a little bit more complicated and say, what if we have a cube root? Doesn't matter. It is to the power of 1/3. So your y dash will be 1/3 x 1/3 minus 1, which is 1/3 x to the power of negative 2/3. As I said, when it comes to fractions, please feel free to use a calculator. Then what we learned was what happens if two functions are multiplied. Just expand it if you can. Here we can expand it and then differentiate it, which is 2x minus 5. And what if it's divided? So something like x plus 1 divided by x. In this case, I'll be like simplify it, and then y dash is just 1. Then we learned how to differentiate few functions. So the first one was, say, e to the power of x. We know it is e to the power of x. As I said, you can write ln of e, but it's 1, so that's why we don't write it. Y equals to 3 to the power of x. The only difference is this will be 3 to the power of x, then multiplied by ln of 3. Then we learned about logs. Log is just, if it's log of x plus 1, it just becomes 1 over x plus 1. And later on you will actually learn that we have to differentiate x plus 1, which is 1. That's because we have not learned the chain rule or composite functions yet, I've just taken it so that it is a simple function here, okay? Any trig function, say if I have to differentiate cos x, I can look at the formula sheet. Differentiation of cos is negative sine x. So in the first video, I've kept it really simple that you have learned how to differentiate all the functions. So you've learned a polynomial, a root function, what happens when two functions are multiplied. If it can be simplified, you should do it. Then I've taken something where it's a quotient, like something like this example here. And then you have learned how to differentiate an exponential function of both types, e to the power of x or a number to the power of x. You have learned how to differentiate a log function and trig functions. In my next video, I will be going through 3 rules, which is differentiating composite functions, product rule, and quotient rule. So watch lesson 2 to learn those.